Okay, this question has to find the approximation has error. So approximation error basically. So let's use the remainder theorem. So remainder theorem says fn plus 1 to the c over n plus 1 factorial x minus a n plus 1, right? That's the equation. And we know it's a second order, so n is 2. So it's going to be Rn of f of 3, c, 3 factorial, and then x at center at a equals 3, so x minus 3, and not n. So it's going to be cubed. Okay, we know this. So what we have to do now is we have to actually find the derivatives, right? So f of x is given that it's ln x, right? So it's going to be ln x. F prime of x is 1 over x, right? And f double prime is, I'm going to write this as x minus 1, so minus x minus 2. And f triple x would be 2x minus 3, right? This is the same as 2 over x cubed. And then we want to find f prime of c, which is 2 over c cubed. So r of n becomes 2 over c cubed times 1 over 3 factorial times x minus 3 to the cube power. Okay, so this is 3 times 2 times 1, so 2 canceled out, so 1 over 3c cubed, x minus 3 cubed, and then x is at pi, right? So this becomes, x is pi, so this becomes pi over minus 3 cubed over 3c cubed. So this is E. So the answer is E. Okay. This question has to find all the values of P such that the following series converge. We're going to use P series test and we're going to just plug in the values. So I'm going to plug in the values that's bigger than the denominator, like P equals 5, to make it into 1 over NP format. So if I do P equals 5, this becomes k to the 4th plus 2k squared over 3 plus k to the p. And if the k goes to infinity, then this becomes just k to the 4th plus 2k squared plus 3 plus k to the 5th. This wouldn't matter. 2k squared and 3 doesn't matter because we just care about the highest, highest term, highest power. So this will be just 1 over k, right? 1 over k square root. So 1 over k, this will be 1 over, right, k minus 1/2, like that, right? So since this is like that, which means p is 1/2 and p is less than 1, so it's diverging. So this is not right. So p equals 5 shouldn't be included. That means E is not right. Let's check p equals 6. P equals 6 is k to the 4th plus 2k squared, 3 plus k to the 6. 2k squared and 3 doesn't matter because if it goes to infinity, it's a very trivial number. So this becomes 1 over k squared. This means 1 over k, which is p equals 1. So it's diverging. So p equals 6 shouldn't be included. That means D is not right and A is also not right. I forgot to get rid of it. By doing this way, you get rid of 3 options. So now you can check p equals 7. Let's see, k to the 4th plus 2k squared over 3 plus k to the 7th. 2k squared and 3 doesn't matter. So this is just 1 over k to the cube, right? So this is k minus 3 over 2. So p is 3 over 2, right? So since p is 3 over 2, and that value is bigger than 1, you can say that that's converging, right? So p equals 7 should be included. That means it's gonna be B, right? That B includes the p equals 7, and C does not. So B is the right answer for this question. So the answer is B. Okay, this question has the series, and then you have to evaluate that whether it's converging or not. So let's see. K equals 2 to infinity 1 over k ln k squared. So let's use integral test. So integral test, So then it's going to be 1 over k ln k squared dk to infinity. That's a weird 2. I will rewrite it. So if you do that, then if you put u as ln k, du is 1 over k dk. So this becomes 1 over u squared du, and then you have to write a new bound. u1 would be ln 2, u2 would be ln infinity, which is infinity. So ln 2 to infinity. And then this is ln 2 to infinity. You can rewrite d over u squared as u minus 2 du. So this is minus u minus 1, ln 2 to infinity. So if you integrate this, this is negative 1 over infinity plus 1 over ln 2, which this goes to 0. And so this barely actually converges to 1 over ln 2. So that's the answer for this question, but we're just going to go over all the other options. So we just checked converging by integral test, so B is not right. So C, diverges by the divergence test. So if you plug limit k goes to infinity, 1 over infinity times ln infinity squared, which is 1 over infinity. So this is just literally going to ln, so k goes to infinity, then 1 over infinity times ln infinity, which is just infinity, right? So it's 1 over infinity and equals 0. So if you get the one a limit goes to 0, then it's invalid, inconclusive. So you can't say anything about divergence test, so this is inconclusive. So C is not right. So D is also not right. So E, divergence by comparison test. Let's check 1 over k and 1 over k ln k squared. Okay, I'll just rewrite it. So since 1 over k ln k squared is smaller, so 1 over k is the bigger one. And we know 1 over k is diverging because of the p series test, because p is 1, because the power is 1. So 1 over k is diverges. So this one is bigger diverges. And if you remember your comparison test, it has to be the small one diverges to tell bigger one diverges. So if you know bigger one diverges, you don't know anything about the small one. So this is also going to be inconclusive. So the E is also not right. So that's why the answer is A. Okay, number 4. According to the root test, the series, you have to evaluate that. Okay, the question said to use the root test, so why don't we use the root test? So square root of, the square root of k, I guess. Sine 1 over k to the k power. K canceled out. So sine 1 over k, right? And then k goes to infinity. This is going to be sine of 1 over infinity, which is sine of 0, which is 0. 0 is less than 1, so it converges, right? So it converges, so we can get rid of C and D and A. So it's either going to be B or E, but we know that in the root test, the condition has to be the p value, or like the evaluating value has to be less than 1, right? So this p is this p or rho, actually rho should be less than 1 because that's the evaluating condition. So it's just asking whether you remember your root test condition. So which is why the answer is E. Okay, this question asks which of the following statements are true. Okay, let's look at the first one. So limit n goes to infinity, a n is 0, then n equals 1 to infinity, a n converges. Okay, so if we say a n as maybe 1 over n or something like that, then limit n goes to infinity, this is 1 over infinity, so this is 0, right? But if you remember your p series, 1 over n actually diverges because p is 1. So this is not converging. So the statement 1 is wrong. So A1 is wrong. That means you can get rid of C, D, right. So let's check 2. So n equals 1 to infinity, absolute value of a n converges. Then n equals 1 to infinity, a n converges. If you remember your absolute convergence, So absolute value converges, then it has to be the smaller one, or just the one without absolute value has to be converging, which means 2 is right. So you just have to remember your absolute convergence thing. So 2 is right. So 2 is right. That means A is not right. So it's going to be B or E. Okay, let's check 3. So if the sequence AN is decreasing, okay, then n equals 1 to infinity, negative 1 to the n plus 1, AN converges. Okay, so let's check. N equals 1, infinity, okay, sorry. AN is decreasing. Then n equals 1 to infinity, negative 1, n plus 1, AN converges. So since there's a sign alternating going on, we're going to do alternating series test, AST. So since AN is decreasing, you can say that it's going to be either, so if you remember your AST conditions, it has to be decreasing, right? And it has to be limit of AN goes to 0, right? So that means this one doesn't actually satisfy the condition because we don't know limit of AN goes to 0. So you can't just say that it's converging. It can be diverging if it doesn't equal to 0. So you can say that. So we don't know for sure. This is not right. So that means B is not right. That means E is the right answer. So E is the right answer. Okay, number 6, compute that thing. Okay, so, I can use geometric series, right? So geometric series, so if you remember geometric series, S to the infinity, A over 1 minus R, A is the first term, R is the ratio. So let's write in the format that we can actually write. And then, the one thing I forgot to mention is R, the ratio, absolute value of R has to be less than 1. Okay, let's write the format into that, like to the ratios, because we have k plus 1 in the power. So k equals 1 to infinity, negative e k plus 1 over 5k. Since we have k plus 1 in the denominator power, we can write this as k equals 1 to infinity, negative e times negative e to the k over 5k. Take it out the negative e outside, negative e, k equals 1 to infinity, and then this is going to be negative e k over 5, right? I'll just rewrite it in the format negative e to the k over 5k. So since they both have k like power, you can group them. So this is going to be negative e, k equals 1 to infinity, negative e over 5k. Okay, we have that. So now we know the ratio, and this ratio is actually less than 1. Because e is around like 2 point something like that. So 2 over 5 is apparently less than 1. So, okay. So we know for sure our ratio is less than 1. So you can use the geometric series. So let's use that. S to the infinity. S to the infinity is equal to a over 1 minus r. So our first term, a, would be negative to the 5, right? And then r is negative e to the 5 as well. So if you find the sum of this thing, s to the infinity is negative e over 5 over 1 minus plus e over 5. So this is negative e over 5 over 5 plus e over 5, which is just 5 over 5 plus e in the denominator, negative 5e, 5 canceled out, so negative e over 5 plus e. Okay. And then don't forget to multiply with negative e because we took it out. This is negative e times negative e over 5 plus e. This is e squared over 5 plus e. So the answer for this question is E. Okay, this question asks which of the following series converge. Let's check that. So k equals 1 to infinity, 7 to the k factorial plus 10. So I see the factorial and k, so I'm going to use the ratio test. Ratio test, so 7k plus 1 over k plus 1 in factorial plus 10 right? And divided by the original, which is the reciprocal of this thing, so which is 7k, k factorial plus 10. So, and this thing, and limit k goes to infinity. So if it goes to infinity, 7k plus 1 and 7k would be just like, actually let's separate it first, right? So 7k times 7, right? 7k plus 1 can be written as 7k times 7 to the n 1 power. And then k plus 1 factorial is k plus 1 times k factorial. I'm separating it this way so I can actually get rid of things. Plus 10 times k factorial plus 10, 7k. So if it goes to infinity, plus 10 would be very trivial number, so it wouldn't matter. K factorial will be cancelled out. 7k can be also cancelled out. So limit of k goes to infinity, 7 over k plus 1. And then if you actually plug it in, this is 7 over infinity, which is 0, which is less than 1, so it converges. So 1 is right. Oopsie, 1 is right. So that means B, C, E are right. B, C, E can be our option, not D and A. So let's look at the second option. The second option is 2 plus -1 to the k over 2k. I'm going to use ratio test again. I love ratio test. I think it's the most simplest one, honestly, to me at least. Limit of k goes to infinity, 2 plus -1 to the k plus 1 power over 2k plus 1. Divide by the original, which means you just have to flip it. So this is 2 plus -1 to the k with denominator, and denominator will be 2k. I'm going to separate this into the way that you can cancel out. So 2 plus -1 to the k times -1, which is same as -1k plus 1, over 2k times 2, which is same as 2k plus 1, times 2k, 2 plus -1k. 2k cancelled out, right? And then -1k will be also cancelled out, plus 2 will be cancelled out. So we're just left with -1 over 2, which is in absolute value, means 1 over 2. This is less than 1. So you can say that it's also converging. Okay, I like that. That means 1 and 2 is right, so B is not going to be the answer, so it's going to be or E. So the third one. Okay, right. K equals 1 to infinity, sine 1 over square root of k. Okay, so if you remember your sign, it's gonna be just like oscillating from -1 to 1, right? So it doesn't converge any value, which means this is just gonna be not converging. So 3 is right, 3 is wrong. Sorry, so that means it's gonna be option E. So the answer is E. Okay, this question asks for which of the following series the ratio test inconclusive. Let's try it. So A, k plus, okay, maybe not. A, k plus 3 over 5k minus 1, right? And k equals 1 to infinity. So if the limit of k goes to infinity, this becomes k plus 1 plus 3 over 5k plus 1 minus 1 times the reciprocal of the original, so which means k plus 3, 5k minus 1. So this one becomes limit k goes to infinity, k plus 4 over 5k plus 4 times 5k minus 1, k plus 3, right? So the numbers will be trivial, so it doesn't matter. So this becomes just k times 5k, 5k times k, and limit goes to infinity. Limit of k goes to infinity. So that means, yeah, I'm just erasing the stuff. Right. So limit of k goes to infinity. That means k cancelled out, 5k cancelled out. So this is 1. And you know that limit of like k goes to infinity, it's just 1, and you get the result of 1 for the ratio test. And you know that ratio test, if you get a 1 for our result, it's inconclusive. That means A is our answer, right? So, well, I can't like click on it apparently. So, okay, A is our answer. but we're just going to check the B, C, D, E stuff. So let's try B. So B is k equals 1 to infinity square root of k over k factorial. So limit of k goes to infinity, you add another like plus 1, so square root of k plus 1 over k plus 1 factorial times the reciprocal of the original, which is square root of k factorial. This canceled out. So this will left with k factorial over k plus 1 factorial. If you don't know why this canceled out, because it's just a trivial number and it's the square root, and you just have, like whenever you do the ratio test, you just have to check the power, not the number itself. It's added. Because the power for square root of k plus 1 would be k to the 1/2 power, and the square root of k is also k to the 1/2 power, so they're the same power, so you can cancel them out. Which is why we are left with k factorial and k plus 1 factorial. This is k factorial over k plus 1, k factorial, which cancelled out, then it's going to 1 over k plus 1. And you know that 1 over k plus 1, and then k goes to infinity, this is 1 over infinity, which is 0, which is less than 1, so it's converging. So B converges. Okay, that's good. So B converges, and A is the answer. So C, let's try it. K goes to 1 to infinity, k factorial over 2 to k power. So if you put the ratio test, you have to add plus 1, k plus 1 to infinity, not infinity, k plus 1 factorial over 2k plus 1, absolute value, reciprocal of the original, k factorial to k. So this is limit of k goes to infinity, k plus 1 times k factorial over 2k times 2 times 2k over k factorial. K factorial cancels out, 2k cancels out. So I wrote it this way so I can actually cancel out things. So limit of k goes to infinity, k plus 1 over 2. So this is just a limit of k goes to infinity, infinity over 2, which is infinity. So if you remember your ratio test, if it's infinity, then it's gonna be diverging, because infinity is greater than 1. So C is also not right. So let's try D. I'm gonna move this. So D is negative 10 to the k over k times 7 to k plus 1. So if it limit of k goes to infinity, there's a sigma. So negative k plus 1 over k plus 1 times 7 to k plus 1 plus 1. Multiplied by the reciprocal, which is negative 10k, k times 7 to k plus 1. So this becomes limit of k goes to infinity, negative 10k times negative 10 over k plus 1 times 7 2k plus 3, I think, yeah. And then times k times 7 to k plus 1. Okay. And then over negative 10k. Let's cancel out. This thing canceled out. Then what else can be cancelled out? K and k plus 1 can be cancelled out because they're the same power, just first power. So we are left with negative 10 and 7 to k plus 1, and then 7 to k plus 3, which I'll write it down. So this is limit of k goes to infinity, negative 10 times 7 to k plus 1 over 7 to k plus 3. I'll write it in the bottom. Limit of k goes to infinity, negative 10 times 7 to k times 7. I'm just separating out so you can cancel out the 7 to k eventually. 7 to k times 7 3, which is same as the 7 to k plus 3. So this cancels out. So this just eventually becomes, this also can be cancelled out to 7 to the squared. So limit of k goes to infinity, negative 10 over 7 squared, which is 10 over 49. 10 over 49 is less than 1, so you can say that it's converging. That was a long one, right? Okay, let's do E. I'm gonna write E in here. So E to the k over 3k. e to the k plus 1 over 3k plus 1. I forgot to write the sigma. And then this is limit of k goes to infinity. So multiply by the reciprocal of the original, which is e to the k, 3k. I'm going to separate it out. So limit k goes to infinity, e to the k times e over 3k times 3 times 3k ek. 3k ek canceled out. So this is e over 3, which e is around 2 point something, which is less than 1. I mean, not less than 1, but like e over 3 would be less than 1 because e is 2 point something. That means this is going to be less than 1. So this is actually converging. Right. So this is also has some like value, not inconclusive. So that means A is the right answer. Okay, this question asks to determine the radius of convergence of the power series. Okay, I love ratio test personally, so I'm going to use ratio test. K equals 1 to infinity, k plus 1, x minus 6, k plus 1, over 3k plus 1. And I'm going to put limit of k goes to infinity, and I'm going to put absolute value. And also divided by the reciprocal, so that means k plus 1, not k plus 1, sorry, k times x minus 6k, and then 3k on the denominator. So limit of k goes to infinity, k plus 1, and over k, I'm going to group them together, and then it's going to be x minus 6, k plus 1, over x minus 6k, and 3k over 3k plus 1. So k plus 1 and k had the same power of 1, so we don't need to care about that. They canceled out. And you can you can change this into the form that you can actually cancel out. So x minus 6k times x minus 6 is the same as x minus 6k over k plus 1. So this is divided by x minus 6 to the k power. And then 3 to the k over 3k times 3, which is same as 3k plus 1. So 3k is x minus 6k, x minus 6k canceled out. So we're left with x minus 6 over 3, right? But then it's saying it's radius of convergence. So it already told you it's converging. That means it's less than 1. So x minus 6 is, so x minus 6 over 3 is less than 1. So this is same as x minus 6 is less than 3. I just moved the 3 in here. So x minus 6, 3 to negative 3, add 6 on both sides, this becomes 9, then becomes 3. So that's our radius of convergence. Oh, that's the convergence like interval, and then it's asking the radius, right? Radius would be the 9 and minus 3, right, over 2. This is 6 over 2, which is 3. So the answer is A. So some people might wonder why I just subtract those, because we're asking the distance, or like in the interval, I guess. So when you have like the midpoint or something like that, or like if you want to find the distance, you have to subtract from the end point to the start point, which is what I did, and then if you divide it by 2, then it'll be your midpoint. So which is why 9 minus 3 over 2 and equals to 6 over 2, which is 3. Okay, 10 asks to approximate e to the negative 0.1 using the second order Taylor polynomial centered at a equals 0. Okay, so if you remember your Taylor, I guess, expansion or something like that, then it's going to be f of x plus f prime of x minus a over 1 factorial plus f double prime of x minus a squared over 2 factorial. But since it's only asking the second order, so I don't have to do until that point. So, and then we also know a is 0, so let's plug it in a as 0, fx plus f prime of x and x, right? over 1 factorial plus f double prime of x squared. I'm going to take out the x so you don't confuse, x times x squared over 2 factorial. Okay, we have that, and then now we have to actually find our derivative, right? So f of x, because we want to find the derivative into the point that actually like find it's at center A equals 0. So that means we have to find f of 0, f prime of 0, then the f double prime of 0 times x squared over 2 factorial. That's why we're going to do that. And then we have to write our function first, which is fx is e to the x. And then f prime of x would be e to the x. F double prime would be the same, e to the x. So f of 0 of e0 is 1, which f double prime and f prime will be also 1 because it's the same value, e to 0, e to 0. So they're all same. So it's going to be 1 plus 1 times x 1 factorial. Yeah, my laptop is overheating, so it's getting slower. Plus 1 times x squared over 2 factorial. So this is just 1. So this is 1 plus x squared over 2, right? That's our equation. And then now we have to plug it in. That value is at negative 0.1. That x is negative 0.1. So let's plug it in. 1 minus 0.1 minus 0.1 squared over 2. And then I'm going to put plus in between. Like so, it's like that. This is 1 minus 0.1 plus 0.01 over 2. Right? So this is 0.9 plus 0.005. So this is 0.905. So the error term is E. Okay, this question has to compute the ln k minus ln k plus 1. Okay, so since we see that, we can use telescoping theories. Telescoping. So if you plug in k equals 1, this becomes ln 1 minus ln 2, right? K equals 2, ln 2 minus ln 3. Right, because I use telescoping series because I know that it's going to cancel out if you plug in the values. So k equals 3, it's going to be ln 3 minus ln 4. Yes, my laptop is getting overheated, so it's getting slower and slower. Love it. Anyways, so if you see it, then ln 2 and negative ln 2, ln 2 and negative ln 2 cancel out, negative ln 3 and ln 3 cancel out. So this is going to be like repeating pattern. So at the end, it's going to be only left with ln1 and the very last variable, which is ln1 minus, if it goes to infinity, ln infinity plus 1, right? Which is ln1 minus ln infinity. ln1 is 0, so 0 minus ln infinity is just negative infinity. So this is negative infinity, which is actually series diverges, which is why the answer is C. Okay, this question asks to find the smallest integer n that can be sure that Sn minus s is less than 1 over 400. Okay, so if you remember your alternate series estimation theorem, R of n is equal to x minus s of n is bn plus 1, something like that, right? So we don't really care about the this part, I guess, or bn plus 1. You can actually write this part as sm plus 1 actually. So we care about this part and then 1 over 400, right? So let's find the sm plus 1 value. Sm plus 1 is negative 1 to the k plus 1 over 2k plus 1. Oh, I should have put that in the parentheses. 2k plus 1 squared, right? So this is negative 1k plus 1, 2k plus 3 squared. Okay, so the series, when you're doing the series, since it has an absolute value, this absolute value, right? So this is just 1 over 2k plus 3 squared. And this value, 1 over 2k plus 3 squared is less than 1 over 400. So cross multiplication. So 400 is less than 2k plus 3 squared, right? So 400, so we can just square root of both sides. So this is 20 less than 2k plus 3. So 2k is bigger than 17. K is bigger than 17 over 2, which is around 8 1/2. Now around, which is equal to 8 1/2. So the smallest k would be 9, right? So the answer for this question is C,